The third type of power found in prescription lenses is prism. A simple prism looks like this. The thinnest point of the prism is called the apex. The thickest part is the base. A prism deviates light toward the base. For example, the normal path for a ray of light is a straight line. If we put a prism base down in front of the light source, the prism will deviate the light and force it to strike the object in a different place. The amount of deviation from the normal, in centimeters, over a given distance in meters, is a measure of the prism's power. One prism diopter is defined as that prism power which deviates a ray of light 1 centimeter from the normal at a distance of 1 meter. Notice that the power of a prism is basically due to thickness differences in a lens rather than on curvature. In other words, prism exists in a lens anytime the two sides of a lens are not parallel. In prescription lenses, the two sides of a lens are parallel only at one point, the optical center. We can find that center and mark it using the lensometer. That's why it's important to properly center each lens before neutralizing and marking it. In the lensometer, prism power is read in diopters directly off the reticle by the displacement of the center of the crossed Myers. For example, this is a plano lens with one diopter prism base down. With nothing in the lensometer, the crossed Myers are centered on the reticle. However, when I place this prism in the lensometer, the center of the Myers is now displaced down to the ring on the reticle marked 1. This signifies a 1 diopter prism base down. A 1 1/2 diopter prism would displace the image to this point. A 2 diopter prism would displace the image to this point, and so forth. The direction of displacement will be equal to the base orientation of the prism. Base up will displace the Myers up. Base down will displace the Myers down. Base in or out will displace the Myers horizontally, one way or the other,